All right, here we go. Today we're going to look at the Pythagorean Theorem a little bit. What is the Pythagorean Theorem? Well, the Pythagorean Theorem says in a triangle, if it's a right triangle, the square of the hypotenuse is equal to the sum of the squares of the two legs. And you go, eh? Well, the easier way to say it is c squared equals a squared plus b squared, where c is always a hypotenuse. And most people get that much easier. Okay? So, c squared equals a squared plus b squared. Okay? Now, if c squared equals a squared plus b squared, then that means we have a right triangle. If c squared is greater than a squared plus b squared, it's obtuse. If c squared is less than a squared plus b squared, it's acute. And we'll get to that later. Okay? But that's the converse of the Pythagorean theorem. If this works, then it's a right triangle. Where the regular Pythagorean theorem, if we have a triangle, then c squared equals a squared plus b squared. So let's look at the ladder guy. A guy puts up a ladder, and it goes 9 feet up against that storage pallet thing. Okay? It's 2.5 feet away from the wall. Did he put it up safely? Because if he didn't, he could tip over backwards. So, let's see if he put it up safely. To figure out if he put it up safely, the base of the ladder has to be 1/4 the length of the wall, 1/4 the length of the ladder away from the wall. So we need to figure out the length of the ladder, which is c, right? Because that's a hypotenuse. So if c squared equals a squared plus b squared, c squared equals 2.5 squared plus 9 squared. What's 2.5 squared? 6.25. 9 squared? So c squared equals 87.25. So you take the square root on your calculator. What would c be approximately? 9.35, something like that. So the length of the ladder is about 9.35 feet. Is 2.5 feet a quarter of that distance? Well, you take 9.35 times 1/4. And what do you get? 1/4 of 9.35. 2.34-ish. Okay. So the minimum the ladder can be away from the wall is 2.34 to meet the 1/4 the length. He put it a little further away. He put it at 2.5. So is he safe? Yes, he is safe. Let's look at another one. A wheelchair ramp. To meet requirements, a wheelchair ramp, for every 12 units you go this way, you can only go up 1 unit. 12 units this way, 1 unit. Okay? Does this ramp meet requirements? Well, what side are we missing? C again? No, we're missing A or B. Let's just call it A. It doesn't matter which side is A and which side is B. They're both legs. It really doesn't matter. But C, you need to have alone. So c squared equals a squared plus b squared. So 500 squared equals a squared plus 41 squared. 500 squared is 250,000. 41 squared is like 1,600. You're really good. 1,681. So if we subtract 1,681 from each side, we get 24,803 and 1. Well, 248,319? Okay. That was just. No, that wasn't memorized from the other class. That was doing subtraction really fast in my head. So A equals, must be 498? The square root of 248,319. 3/16. Okay, whatever. Now let's take that times 1/12, because its rise over run can only be 1/12. So what is 1/12 of that? 41.52. So the maximum this could go up is 41.52. If it's 41, does it meet regulations? Yes. Okay? So that's a little Pythagorean theorem in the real world. As a carpenter, when you're pouring concrete basements, when you're pouring basements, you use a Pythagorean theorem every single time. Okay? Because what we do when we pour a basement, and I haven't poured a basement for years, but we would always do this. Okay, let's say the foundation looks like that. We would measure out 8 feet this way and 6 feet this way, and then measure our two marks away from each other. What would our marks have to be away from each other to make sure that we have a right angle as a corner? How many feet? 10 feet. Why is it 10 feet? Well, it's a Pythagorean theorem. We want to make sure we had a right angle here. Okay? So to have a right angle, c squared equals a squared plus b squared. So c squared equals 6 feet squared plus 8 feet squared. C squared equals 36 plus 64. C squared equals 100. C equals 10. Now, the guys I worked with had no clue they were doing the Pythagorean theorem. They just knew that if they went 8 feet this way, 6 feet this way, that had to be 10 feet. Of course, me as a math teacher knew that was the Pythagorean theorem. They were like, oh, the boss just told me that. We just learned it that way. Doesn't matter. Okay? This is the Pythagorean theorem. Pythagorean theorem is used all the time in construction. Okay? All of the time. All right. Now, let's say we have this. Let's say we have a triangle that's 4, 3 square root of 2, and we want to find the hypotenuse. Ooh, 3 square root of 2. How do we do that? Well, c squared equals a squared plus b squared, right? So c squared equals 4 squared plus 3 square root of 2 squared. If you want to figure out how to square 3 square root of 2, because 4 squared is 16, 3 square root of 2 is 3 squared times the square root of 2 squared, or 9 times the square root of 2 squared. Square root of 2 times square root of 2 is square root of 4, which is 2. When you square a square root, you get what's underneath. So if you had like the square root of 137 and you squared it, what would that be? 137. Okay, when you square a square root, you get what's underneath. 9 times 2 is 18, so c squared equals 16 plus 18. What's 16 plus 18? 34. If we take the square root of each side, c equals the square root of 34. And sometimes they say to leave it in simplest radical form. That's simplest radical form. Can't be broken down anymore. Okay? Let's do another one that they tell us to leave in simplest radical form. Let's say we have 12 on this side and 10 on this side. Oop, no, not that side. That's a short side. Let's make it 10 on this side. Okay, 10, 12. This side we can just call A. 12 squared equals A squared plus 10 squared. What's 12 squared? 144 equals A squared plus 100. If we subtract 100 from each side, 44 equals A squared. Take the square root. Simplest radical form is not the square root of 44. Because if you have a number on this list that goes into it, okay? And these are a list of gazintas. You know what a gazinta is? Robin Williams movie? You didn't never watch one of those Robin Williams movies which it talked about gazintas? These are numbers that you look to go into this. Go into, gazinta, gozinta. Yeah, old guy joke. Okay. So, which is the biggest number on this list that gazinta 44? Does 16 go unevenly to 44? No. 4 does. It's the square root of 4 times the square root of 11. What's the square root of 4? 2. So it's 2 square root of 11. That's simplest radical form. Okay, simplest radical form. Today on your assignment, I bet one of your answers will be the square root of 56. So you got to find the biggest perfect square goes into 56. 4 goes in there 14 times. So what's the square root of 4? 2. Square root of 14 doesn't break down. So you leave it as what breaks down and what doesn't break down. Okay, one other thing today. If c squared is less than a squared plus b squared, you got a good looking triangle. You got an acute triangle. If c squared equals a squared plus b squared, you have a right triangle. And if c squared is greater than a squared plus b squared, you have an obtuse triangle. So, if you have a triangle that's like 10, 12, and 14, what type of a triangle is that? Well, which is C? 14. The biggest number is always C. So 14 squared, compare it to 10 squared plus 12 squared. 14 squared is 196. Compare it to 100 plus 144. Is 196 greater than, less than, or equal to 244? Less than, so this is a good-looking triangle. It's an acute triangle. What if we have sides of 6, 4 square root of 2, and 9? 6, 4 square root of 2, and 9. Well, what's the longest side there? What's bigger, 4 square root of 2 or 9? Well, you gotta do the math. I would punch it down in the calculator. What's 4 times the square root of 2? 5 point something. So that's our shortest side. So you compare 9 squared with 6 squared plus 4 square root of 2 squared. What's 9 squared? 81. Compare it to 36 plus 4 times 4 is 16. Square root of 2 times square root of 2 is 2. 16 times 2 is 32. So 81, compare it to 68, and it's greater than, so this is obtuse. Okay? So that's how you're going to do your worksheet today. You got a worksheet? I will hand it out now. You get out of here at 14, right? Yep. So that'll be about a half hour, a little less than a half hour for you to work on this. So read the directions, because sometimes it wants a decimal answer, sometimes it wants the answer rounded to the nearest 10. So make sure you read the directions. Yes, you may go to the bathroom now. You're welcome.
Is this a good calculator for your class? I need to order
Yes.
a calculator. That's a
Yeah,
good one
that's
right there.
the one that we use.
Okay, I'm gonna order it right now. Thank you.
Can I go to the bathroom?
Mm-hmm.